Hello and welcome. Today is Tuesday, April 21st. I'm not sure if you guys got the update from Mr. Hussey, but I will give it to you right now. We have a slight change in our schedules from here until the end of normal school days, which is the end of May. We'll be holding our stream sessions and classes and etc. 4 days a week. 4-day schools. 4-day school week, which means Monday, Tuesday, Thursday, and Fridays only. On Wednesdays, us teachers will be in meetings, department meetings, and other stuff online, and so no streams on Wednesdays. Okay, so it's just tomorrow I'll be in, I don't know, whatever. So tomorrow, no streams, no stream tomorrow. So we'll go on to a Monday, Tuesday, Thursday, Friday schedule starting this week, really starting from today. But thankfully I have, I've opened up all of your assignments for the rest of May all the way to pretty much the end of the school year. So all of your things are ready to go, and I'll talk about that. I guess we'll do it right now. So you should go to your now. I've seen that some of you, typically the students who have been doing well in the class, have already been doing all of this stuff already. A majority of you, especially those who have been struggling, have not been doing it. Oh, it's not due, so might as well not do it. So those of you who need some extra push and some extra guidance, I guess I'm here for you. If you go to your myap.com, the multiple choices and of course the FRQs are also ready, but the MCs you'll get to see, get some feedback. They now have due dates. Okay, so every Friday night expect to do my AP. I believe unit 1 and 2 due this Friday, 4/24. Now it says 4:25, 12 a.m. So that means Friday midnight, by the way. So I would, if I was a student, I would not wait until midnight, of course. I would do Friday 24th, 11:59 to be safe. Okay, and then 3 and 4, it's the following week, which is, it's May. Uh, 5 through 7 is May 8th. Now, of course, you take your test the following week. And then on the 15th, 8, 9, let me make sure I did this right. May 22, 29, oops. Okay. So those of you who are done, you're one step ahead, I suppose. But a lot of you are not, especially period 4 students. Period 4 students, you guys have not been doing all of this at all. So you have quite a lot more work than period 2 students, it seems. So here are due dates, and then so you can expect to do some. So if you don't see me on Wednesdays, well, you know what to do. Go to myap.com and do your work. All right. Okay. All right. Let's talk about yesterday's problem. I left you off with part C, which is to find the tension. And a couple of you participated. Thanks for your participation. Unfortunately, we didn't do it right, so we need to go over this again. Some of you were close, and then it just fell apart at the end during your explanation, and you arrived at the incorrect conclusion. So if you recall, we had a wheel with a mass hanging. It's a classic windmill type problem. Okay, we arrived at the sigma equation where we said that Ft is now equal to mg plus ma, but, you know, or I shouldn't say but, I should say that after coming to this conclusion, you suggest that, oh, whichever accelerates the fastest must have the most tension, and so it led you to the same answer as before, CAD. But think about it this way. Right? Look at the vectors. Look at the vectors. Here's mass, the hanging mass. Tension is upwards, while mg is downwards. Okay? It is falling down. The acceleration is downwards. The net acceleration. The net acceleration, A, is a negative value. Okay, this is a general formula for your sigma f. But based on what happens to m, we can tell if tension is greater or not. Okay, A is a negative number. Okay. If you're accelerating downwards really quickly, would that indicate that you have a very high upward force? Does that make sense? If you had a very high upward force pulling you up, would that ever equate to a very quick downward acceleration? No, those two are impossible. You can't be falling down very quickly while being pulled upwards with a greater tension force, right? Or mathematically, I know some of you were close mathematically, but you had a plus sign and that led you astray. You're adding a negative number, meaning you're subtracting a value. Okay? The one that's going to accelerate downward the quickest will have the least tension. Okay? The bigger the negative A is, the less tension you have on the mass. And that should make sense in that the less upward force you have, the more likely you're going to fall downwards and you're going to accelerate more as you're falling. Now, of course, without any of this tension, we would fall at free fall, and our acceleration would just be negative 9.8. Right. One way to not mess up with these negative signs is to use like a linear model. Instead of looking at it where down is always negative, right? You could also say that downwards is positive and rewrite your equations. But the other way is to just visualize it, perhaps tilt your head to the right or tilt the entire system 90 degrees to the left, counterclockwise. So if I were to redraw this, here's our wheel, here's our hanging mass, and it looks like this now. Okay, so let's do this. And by looking at it sideways, you can see how mg is now pointing to the right and ft is pointing to the left. And now the object is accelerating to the right. A is now a positive number as the system accelerates to the right, So if I were to write a sigma equation, we would write that mg minus the tension is equal to ma. It's always ma, but here a is now a positive value. Okay, and so tension is equal to mg minus ma, a being a positive number. So the quicker it accelerates to the right, the less force you have. Okay. How does this change the torque equation? Well, the pulley is still going to rotate clockwise. So if I were to write a sigma tau equation, I get a clockwise torque. So this is where the negative sign comes for the torque. A clockwise torque is a negative torque times radius times the tension force is equal to moment of inertia times alpha, of course. And finally, we have to relate A and alpha. Normally, the general formula is A is equal to alpha. Okay, but notice how a positive A, when A is positive, it's moving to the right. A positive A equates to a clockwise torque. Therefore, it is negative alpha. So that's the only difference. A is now negative alpha instead of alpha. So alpha is equal to negative A over R. All right, so if I remember the systems correctly, let's see. A was masses close in. B was masses further out. And C is no masses. So again, based on the fact that A is a negative, if it's falling, A is a negative number. Or if you do it in the linear model, whichever falls the fastest must have the smallest ft. So in terms of speed, C was the fastest, and then A was next, and then B was the slowest. Whichever is fastest must have the least force. So Ft from big to small would be opposite. BAC, back. So the slowest one has the biggest force pulling it upwards. So, conceptually that should make sense. You're going to fall down slowly if you're being pulled upwards with a greater force. Right? Imagine sliding down a rope. Maybe you're escaping. You're some super secret spy agent, and you're escaping some crazy building. I don't know. You're in a movie or something, and you're holding on to a rope. So, of course, as you slide down, the more friction you have pulling you up, as well as tension and whatnot. The slower you will accelerate. So why not just write Ft equals mg minus, well, you don't just write it because it makes sense. You write it because it works with your model. Okay. Once you establish your model, you have to stay consistent in how you do all of your FPDs. Right? If you establish that going downwards is the positive y-axis, and going upwards is the negative y-axis, then yeah, then you may use that model. But you have to establish that and be consistent when you do all other sigma equations that way, right? If you've been doing down is negative all this time, then to stay consistent, you have to do it the other way. All right. So we were supposed to have a quiz tomorrow, but so no new stuff will be posted on Wednesday, so you won't even see a Canvas thing for Wednesdays now. It just goes straight to Thursday. So expect to do a small quiz on Thursday. I'd like you to go get your work done. Go to the My AP and start working on those things. And then on Thursday we should expect a small quiz. Okay. Thanks for tuning in. Today was just about updates. The update was that we're going to a 4-day week, with Monday being teacher meeting days only. You have My AP homework for the rest of May, at least the MC part. The FRQs are open. You should at least do the FRQs for practice. I will open up the units that are not on the AP test after the AP test. So after, recall that the AP test is May 11th. May the 11th be with you. May 11th AP1 test. So after May 11th, you can see the FRQs for the later units. Will you be posting answers for the FRQs? Well, we will discuss them during the streams and stuff. Is it 14th or 11th? Oh, let's make sure. Oh, 11th is the APC test. You are right. AP Physics C is 11. You guys are on the 14th. AP1 is on the 14th. Yeah. So FRQs will be done during stream. I could do the APC test. Well, I don't think College Board will allow people to sign up for tests at this time, so sorry. Yeah. Yeah. Next year. Next year it's gonna be easy. Yeah. All right. Thanks for tuning in. Go do your My AP stuff. I'll see you Friday, I guess. See ya.